Hi guys, this is Mrs. Gonzalez. This is our first lecture, 1.5, on significant digits. The main objective of this lecture is for you to identify how many significant digits are in a number set and also how to round correctly, because that's been a big question every time we do some work problems. So there is certain rules for rounding when you are adding or subtracting, and then there's a different set of rules when you are multiplying or dividing. So stay tuned. All right, so let's start. I am going along with the PowerPoint. So as you watch this video, you should definitely look at your notes, look at the PowerPoint, pause if there's any time that you are confused, or and write down the question, and then maybe have your questions written down. If they're not answered at the end of the video, then for sure email me. And we can also, as you know, we have office hours set up for YouTube Live. So let's start with the definition of a significant digit. A significant digit is anything that's measured in the lab. It has a physical meaning. And why do we study significant digits? Because we always want to know how to round correctly. Okay, we want to know how many decimal places do I have to add? How many digits? Where can I stop writing down? Where do I start rounding? But before we learn how to do this, we literally need to figure out how do we count a significant digit and what counts as a significant digit. So, the 5 rules for significant digits are: first, all measured numbers are significant. So basically any number, this basically means any number from 1 to 9 is considered significant. And number 2 kind of states the same thing. All non-zero numbers are significant. So anything that's not a zero, guys, which is basically 1 through 9, is considered significant, okay? Middle zeros are always significant. And I will give you an example of what a middle zero is, but a zero that's between 2 numbers, basically a number between 1 and 9, that is considered significant. Trailing zeros are always significant. Are significant, my bad, if there is a decimal point. So in any way that you see a decimal point in your answer or in your calculator, and there's a trailing zero and there's a decimal place, that is significant. We will obviously look at examples of this. And last but not least, leading zeros are never significant. So right now I want you to look at these rules. These are just rules right now. They might not make too much sense, but once we actually start doing examples, I feel like they will make a lot more sense. So let's start with the next slide. What is a middle zero? So middle zeros we know are important. And then let me give you an example of a middle zero. 102.5. And again, this goes along with your PowerPoint. We know that this is a zero, and this gives it a different meaning. And from a number, for example, 112.5, this zero is considered significant because this gives it a different meaning, so different measurement, compared to 112.5. Okay, so this becomes significant in this case. Let's look at ending zeros, or what we call trailing zeros. Trailing zeros, the rule was, are significant if there's a decimal point. So for example, your next number set is 125.0. Why is this zero significant? Because this zero demonstrates that this measurement's a little bit more precise, so it gives it precision. So this is the reason why this zero, because there's this decimal point right here, becomes significant, more precise, means it was measured more correctly. And last but not least, what is a leading zero? A leading zero is something like this. 0.0127. These are called leading zeros. These are never significant. Now, not significant does not mean you shouldn't write them down. It just means that they really, they don't really affect the position. They more affect kind of where the amount of this 0.0127. So again, middle zeros are always significant no matter if there's a decimal point or not. Trailing zeros are significant only if there's a decimal point, and leading zeros are never significant. So obviously, as you can see, zeros are the ones that are basically going to be the most tricky in this point. It's when are they considered significant, when are they not considered significant. That's what you need to make sure you understand. So if we saw the rules for the zeros, the last 5 rules, we can actually sum up everything into simple rules. So for example, no decimal point. How do I know how many significant figures are there? So if you don't have a decimal point, count from the first non-zero number. So remember, a non-zero number is considered a number between 1 and 9. So count from the first non-zero number to the last non-zero number. So again, this is for no decimal point. If there is no decimal point, you count from the first non-zero number to the last non-zero number. How about if there is a decimal point? So what happens when we do have a decimal point? When we do have a decimal point, you count anywhere, you count from the first non-zero number. So the first number that you appears, that's from 1 to 9, count from the first, sorry, that is pretty bad. Let's go back to black. Let's go to black, actually. Count from the first non-zero number. So count from the first non-zero number that you see to the very end. Okay, so again, remember, the decimal makes zeros significant. The decimal is kind of the big key in what becomes significant, what is not significant. So I want you guys to pause the video here. I want you to try the first example of that one that says summary 1 rules. All of these examples, you will see there's 4 examples. All of these do not have decimal points. So we have 124, 20,000, 570, 200, and 150. So pause it here. Try to figure out how many significant figures you see here. So now that you've paused it and you've gone through it, let's see if you're correct. So the rule says if there is no decimal point, count from the first non-zero number to the last non-zero number. If you remember, what is a non-zero number? A non-zero number means any number between 1 and 9. So let's look at the first example. There is no zeros. In 124, there is absolutely no zeros. The first non-zero number is 1 because 1 is a number, obviously, between 1 and 9. The last non-zero number is 4. So how many significant digits here? There's 1, 2, 3. Your answer for the first one should be 3. How many significant digits are in 20,570? Well, our first non-zero number, remember, just how we read any books, we also read numbers that way. We start from the left and we go to the right. Our first non-zero number is 2. Our last non-zero number is 7. How come 0 is not considered a non-zero number? Because 0 is a 0. So how many digits are between the 2 and the 7? 1, 2, 3, 4. There is 4 significant figures here. Third one, 200. The first non-zero number is 2. And this is where kids always get stuck. What's my last non-zero number? Well, in this case, 2 is your first non-zero number and it's also your last non-zero number. So here we only have one significant digit, okay? How about 150? How many significant digits are here? Well, 1 is our first non-zero number, and then our last non-zero number is 5. So here we only have 2 significant digits. So this is the first half of your quiz. Something very similar to this. How many significant figures are in a number set? So now I want you to pause the video again, try the ones that say example, summary, rule 2. So all of these examples are when there is a decimal place present. Again, there's 4 examples. First one being 0.00240. All right, the next example is 240 decimal, and I'm going to make these decimals thick enough so you guys can see them. I'm sorry about the glare. Next example is 370.0, and last but not least, we have 0.02020. Okay, pause your video and try to figure out how many significant digits are in the following. All right, now that you figured it out, let's look at these examples. So the rule says if there is a decimal point, and you can see all of these have a decimal point, you count from the first non-zero number, basically the first number from left to right that you see is between 1 and 9, and you count till the very end, basically till the number set ends. So let's look at this example. As you can see, we have 3 zeros at the beginning. These are known as leading zeros. And if you remember from the beginning slides, leading zeros are never significant. That means that I'm going to start at 2. Okay? So that's my first non-zero number, and I'm going to count till the very end, which is at the 0. So how many significant figures are in these? And this is 3. Okay? Let's count the next one. Again, we start with the first non-zero number from left to right. That's 2. Okay? And we count till the very end because there is a decimal present there. And how many significant digits do we see here? Also 3. Next one, 370.0. Again, we count from the first non-zero number, which is 3, till the very end. And how many significant figures do we see here? That is 4. Last but not least, how many sig figs do we see here? Well, we start with 2 leading zeros, never significant. We start at 2, and we count till the very end. So here we see 4 significant figures. So just a reminder, guys, just because the 0 is not significant, we're counting how many significant digits we have in a number set. But because their digit is not considered significant, it doesn't mean you don't have to write it. So just remember, just like before, basically 25 and 250, yes, both of these have 2 significant digits, right? However, we still have to write the 0 because this gives it a different value from 25. So still have to write it in an answer. Doesn't mean, okay, it's not significant. Ms. Gonzalez, it's not significant, so I don't have to write it. No, because obviously 25 and 250 have a different value set. So you still have to write it. Don't forget to write your zeros. So I want you guys to pause the video again. I want you to try these 5 and see how you do, okay? So now that you've paused the video and you've tried these, let's see how many significant digits there are. So start again. There's no decimal places here. So remember the rule. There's no decimal places. That means I start from my first non-zero number to my last non-zero number. So my first non-zero number is 1. My last non-zero number is 2. So in this case, I have 3 significant digits. Doesn't mean I don't have to write the 0, just not considered significant. Next step, I do have a decimal place here. So I count from my first non-zero number. Remember, we start from left to right. So that is 2. My last non-zero number this till the very end. So the very end is 5. So how many significant digits do I have here? I have 3. Now again, count from the first non-zero number, which is 1, because there's a decimal point, to the very end. So how many significant digits do I have here? I have 4. Next one, there is no decimal point, so count from the first non-zero number to the last non-zero number. Here, again, I have 4 significant digits. And lastly, 10.320, because there is a decimal point, I count from the first non-zero number to the very end. And here, I have 5. So now we're moving to the second part, which is how do we round when we are adding, subtracting, multiplying, or dividing. And the saying goes, basically, if you're in a team, you're playing a team sport, they always tell you you're only as good as your weakest player. Same thing with significant digits. You're only as precise as your least precise measurement. So there's 2 rules. There's 1 rule for addition and subtraction. There's 1 rule for multiplication and division. So what is the rule for addition and subtraction? What do we do then? So basically, your answer has the least number of decimal places as it appears in your as it appears in the problem. So you're always, for addition and subtraction, you're only looking at the decimal place. How many decimal places does the the 2 or 3 or 4, whatever, how many numbers you're adding, you are putting the number of decimal places with the least amount in the problem. Number 2, so how about, sorry, not number 2, but how about for multiplication and division? God, I forgot red, this makes such a good multiplication and division. So what do we do for these? So your answer should have the least number of significant figures. As it appears on the problem. So for multiplication and division, you're looking at the whole number set. So which number has the least number of significant figures? That's how many significant figures your answer should have. So let's do this first problem. So how would we add this? Well, adding it, we add it simply the same way. So you start off the same way, just like you've learned before. 2 plus 0 is 2. 5 plus 0 is 5. 5 plus 2 is 7. We bring down the decimal point. 5 plus 1 is 6. 1 plus 0 is 1. So your answer here should be 16.752. But now rounding it, we do have to round this. And how do we round this? So if we look at the first example, how many significant figures do we have after the decimal? But remember, all the time, with decimals, we always come from the first non-zero number to the end, but we're only interested in after the decimal. There is 3 decimal places here. And how many decimal places is there in the bottom one? There's 2 decimal places here. And basically, the one with the least amount of decimal places is the least precise, which means that your answer can only be as precise as your least precise problem. So our least precise is 1.25. That means that my final answer should only have 2 decimal places. That means that I should only have included 16.75. Now, obviously I can simply cut this one and say 16.75, but you always have to remember, whatever you're cutting off, make sure it doesn't make the number round up. So 2 doesn't make 5 round up because 2 doesn't, it's not greater than 5. So your final answer should only be 16.75. So how about for 10.25 minus 2.42? Now, just to not confuse you, let's make sure, I'm going to do this in the calculator because I want you to make sure that you count how many decimal places were in the original problem. So if you grab your calculator and you do 10.25 minus 2.242, you should get the following. You should get 8.008. Now, just so you're aware, your calculator doesn't round to significant figures, okay? It just gives you the problem as it is. And this is your answer when you subtract these two. Now remember, addition and subtraction, you are looking for the one with the least number of decimal places, and that's how many decimal places your final answer should have. So the first one only has 2 decimal places. Okay, this next one has 3 decimal places. So your final answer should have just been 8.00. However, how come I can't put 8.00? Because the number after 0 is an 8, which means this 8 makes this 0 round up to, as we all know, what's after 0, we have 1. So your final answer should be 8.01. Alright guys, now so let's move on to now division and multiplication. As you remember, so addition and subtraction had the rule of you're looking just at decimal places. For multiplication and division, you're looking at the whole thing. So again, make sure you have your calculator or your phone, doesn't matter, and do this on your calculator. So 10.25 divided by 2.7. And if you do this, you should get a really big number, 3.796296296. Obviously, that's not your final answer, but I'm just going to write it here so you guys can have it. It's 3.7966296. I just stopped there, but obviously this is not all you're going to write. So this is always the question, where do I round? Where do I stop? Well, we have to look at both of our problems. So both of these, we have to count how many significant digits we have here. And we follow the rules from the first section. If I have a decimal anywhere, I count from the first non-zero number to the very end. So my top one, 10.25, because there's a decimal, 1 is my first non-significant digits all the way to the end, which is the 5. So this top one has 4 significant digits here. The bottom one, again, decimal present, count from the first non-significant digit to the very end. So that's 2 here. So how many significant digits should my final answer have? The answer is 2. We should have only 2 significant digits. So if we look at our answer, it's 3.7. 3.7 should be our final answer. However, the number after 7 is a 9. What does that mean? That means that the 7 rounds up to an 8. So my final answer is 3.8. So how about multiplication? So this is your next example. Multiplication and division have the exact same rule. So again, grab your calculator, do 1.704 multiplied by 2.75, and you should get an answer like the following. You should get 4.686. Now remember, this is not your final answer, even though like, oh, this is, my calculator didn't give me too many numbers. You still have to count. Which one of these gives you the least number of significant digits? So again, from the first non-zero number to the end. So the very first one has 1, 2, 3, 4 significant digits. The bottom one has 1, 2, 3 significant digits. So my final answer should only have 3 significant digits. So that means it should stop at 4.68. However, before you say my final answer is 4.68, always check the next number to it and make sure it doesn't make the number round up. In this case, it does. The 6 makes the 8 round up, so your final answer should be 4.69. So that's the end of this lecture, guys. The last 3 slides, as you can see, they're practice problems. Your PowerPoint does a really good job at kind of like breaking down how they got the answer, what's the answer. So what does your quiz look like? Because that's always the question. Your first half of your quiz is just identifying how many significant digits do I have in a number set, just like we did the first half. So if I give you 102, I give you 102.0. Those are the kind of problems you will see the first half. The second half will be addition, subtraction, multiplication, and division. The 2 rules that you do have to remember are Addition and subtraction have their own rule of how do you round. You always just look at the decimal places, and the one with the least number of decimal places, that's how many decimal places your final answer should have. For multiplication and division, you are looking at the whole set. So how many significant digits does each problem set have? And then my answer should have the least number of significant digits. Again, if you have any questions, please feel free to email me. If you get lost, always rewatch this video. Don't just watch it once. Sometimes we have to watch it 2 or 3 times to understand it. Get to talk to your friends, see if they can help you. Miss Nichols and I will be having office hours on Wednesday. They are posted on your newsletter, so please look out for your email. Look out for that newsletter. I will also have posted the practice worksheet on Google Classrooms along with the answer key, so do some of those problems. The quiz for this is scheduled on Friday, April 3rd. So again, please study. Please write down your questions and make sure you use your time wisely.